Yeah, there we go. Should be audio now. I'm still getting used to, I have to turn on the Porta Studio, I have to set a track to record, or else it doesn't work, because apparently you have to have it armed for recording for it to record anything, or to output any audio. I have to make sure it's plugged in, because I never have it plugged in. And then I have to turn on phantom power, because this is a, I keep wanting to say dynamic mic, this is a condenser mic, so yeah. I'll get that together at some point. Okay, so as I just typed in the description for the stream, last time was I wasted a lot of time that I didn't have trying to reconstitute our code, but you know what? It's saved now. At some point, I'll actually start committing it to a repo in GitHub so that we really have it stored, but we don't have to reconstitute it. The thing that's going to waste my time tonight is that I want to well, I was getting really prepped for just writing a little utility to inject our assembled code into the Super Mario Bros. 3 NES ROM so that I can just load it in an emulator. But you know what? For shits and giggles, let's push that off just a little bit. And I'm sure there's already a tool to do that, but why go get an easy tool when you can just write a quick script to do it anyway? But why don't we just pick up where I was last time on my assumptions last time that, you know, there's just garbage in attribute memory, and that is why the palette that we set isn't appearing correctly. Mind you, I don't know at all what I'm doing, so it could also just be that I'm setting the palette wrong. But let me just try writing that code and assembling it, and we'll slap it on here, and if it still doesn't work quite right, then we'll break down, we'll make a little script to inject the code we're assembling into the Super Mario Bros. 3 ROM image so that we can, you know, see what's going on and debug it. Whew, 4:30 a.m. I hope you're waking up early, or just pulling an all-nighter, you know, you do whatever you want. So, yes, what we need to do here is look at the PPU attribute tables, because we kind of looked at this last time, but this is what assigns each little 4x4 block of tiles on a given map. Well, I think there's only one map on the NES. I think there's just one background layer to a given palette. So I set up palette 0 theoretically, but when this starts up, there's probably just all kinds of garbage in the attribute RAM, and it's probably something like all F's, so it's pointing to, like, you know, palette number 4 or something. So this should be easy and fast. Let's just write a tight little loop. As far as I can read here, it's saying the attribute values are literally just, it's only palette information. So if I write all zeros to all of the attributes, then that should be that. Like, they should all be set to palette 0. So I guess I'll just throw that in my code. So we know it is, let's see, they say I could just work out how big this is, but it's a 64-byte array. So there you go, that's easy. Prepare yourself for off by 1 errors, as is tradition, but all right, so right now in our code, this is the part where we're setting the palette values. So 3F00, so this code is, just to refresh memory, you have to write to video memory through a port on the video chip, because you can't just, it's not on the same bus, it's completely segregated. The PPU owns its own memory. So you have to write the high byte of your address to this PPU register, then the low address, the low byte of the address to the same register, and then to this register you write the actual value that you want to place at that address in video memory. Reminds me very much of working with the PlayStation, which I have screwed around with a bit. Very similar kind of segregated model. It's probably similar all over, with lots of video hardware on various old consoles. So anyway, this sets what is it? This sets the global background to a black color, and theoretically this sets the first palette 0 color to something, and the second palette 0 color to something else, and the third palette 0 color to something else. So now, after that, let's just write this loop. Fill first attribute table to all be palette 0. So first, let us load x immediate 64, and we'll count down, and as is tradition, that's probably going to have an off by 1 error, and that's in hex, which is incorrect. That would be 40 hex? I don't know. Let me just make sure I don't screw it up and just write it in decimal. 64. Now that we've got 64 in X, let us load 0 into A, and that will be the start of our tight little loop here. You can also, you can definitely do this with, there's a DMA built into the PPU for loading PPU memory. So I think I could probably use that too, but for now let's keep it super duper simple. You sure can see the program. Woo! Thanks for calling me on that. I did that last time too. It's a lot of fun just watching my face talk about what's going on, huh? You have to write your data through a drinking straw. That is very much what it feels like. All right, now that you can actually see my code, yeah, so this is what I'm saying. I'm filling this attribute table, which is a 64-byte array. That just says, here is a palette color and a palette color, or a palette number, a palette number, a palette number, a palette number for 64 bytes. So, getting back to our loop, load x64, that's going to be our counter, load 0 into A, because that's what we're going to write into memory, and write attribute top. And I guess we'll keep this consistent, and we should just be able to store A. Shoot, and I forget this addressing mode. Is it like... Is that a thing? Oh, wait, but right, we're writing to video memory, so it's not that easy. It is gonna be... Right, we're going to load A... Let's see. So the attribute table should be at 23C0, it would appear. So 23, write that to the address register of the PPU, then load a C0, 23C0, store A into the PPU register, which I should really make defines for this, but we're hacking right now. Okay. Right, and actually this will be, oh, this is going to be interesting, because I have to increment what I'm actually writing there. Fun. If I were a better 6502 programmer, this would be trivial. So we actually need to, we're basically wanting to add X to that immediate value. I don't know if the best way of doing that is just to use a location in 0 page and add X to it. Anybody got any thoughts? Anybody else better at 6502 programming? There's got to be a better way. But I think that's just what I'm going to do for right now. So, let us... Yeah, let's load A... At the top of the loop, we'll load a C0. And then we will store A to... I mean, we're not using anything in 0 page yet, so let's just store it to the 0th item in 0 page. And let us... Yeah, so here, I guess we can load a... Thinking. Yeah, let's actually... We'll transfer X into A. I am not good at this. Transfer X into A, which X will be our counter, so that'll keep counting up. Yes. Then we will add with carry. And I don't know if it's necessary, but I'm going to be paranoid and clear carry right before the add with carry. Add with carry the value from the 0 page. Wait, no. No, no, no. You foolish man. You don't have to do that. You can just keep... Yeah. Let's just... Yeah, we can just add C0 to that, can't we? Right. That makes sense. I think that makes sense. So forget this 0 page crap. Right. So X will be our counter, which is going to mean, well, it's fine if we write backwards in memory. I think that's fine. If we count down from 64 to 0, it's the same as going the other direction. We don't really care. So that should be fine. So what we're going to do is, first we write the high order byte of the PPU address for the attribute table to the address register on the PPU. Then we will move whatever is currently in X into the accumulator, the A register. Clear carry because we are paranoid. And then add. Then add C0 to that. That should work, I think. Then we'll store that value to the address register. And finally, we want to store the actual value, which is... I guess we'll just have to load A and immediate 00, 0, and then store that to 2007 was the PPU data register. And then we are going to DEX, hopefully is a command, decrement X. I am definitely going to need to pull up the 6502 reference. And the extra fun thing is, I really haven't done a lot of 6502 programming. I've done a fair amount of 65816 programming, and the 65816 instruction set is mostly the same thing as the 6502 instruction set, but they added a bunch of instructions, so I don't know what... Like, there might be a bunch of instructions that I think exist that are actually not legal 6502 instructions. So that'll be fun. But yeah, DEX. That's a command, right? Control F, that's what we do. Yeah, decrement X. So that'll decrement our current X value. And then, what is branch 0? BRZ? No. Right, because it's going to be... Depending on your assembler, it might support... Because branch equal and branch not equal actually check the 0 flag. Because... internally in hardware, if I'm remembering this correctly, it actually does a subtraction and then checks the... It does a subtraction, throws away the result, and then checks the 0 flag value, or rather sets the 0 flag value in the same way. So branch equal is the same thing as branch on 0. Right? Yes, branch on 0. Hey, okay. I think that's just a sign for me to crack another beer. This is a Friday night stream, y'all. Thank you, Sean. I'll have to lean on you for being apparently fairly knowledgeable with 6502 assembly, because as I've been rambling on about, I know enough to be dangerous, and hopefully I will improve as we go here. Or not. Sometimes you just hack along and get there eventually. Anyway, so break if equal will is the same thing as break branch if 0. And some assemblers actually support using either or syntax. They will assemble to the same instruction. Don't know if this one does, so I'm just going to use branch if equal. And we will branch to, actually we want to branch if not equal, so branch if not 0, right? To the top of the loop. And then if it has become 0, if we decremented x and we're all the way down to 0, which is almost certainly will give us an off by 0 because it will, yeah. I think if I just decrement at the top of the loop, actually, it might work. Because when we just wrote the 1th address and we just got down to 1, then we decrement and then it'll say, oh, it's 0, pop out, so we'll never actually write the 0th address. So I think let's decrement first, because I already think 64 would otherwise be an off by 1. We'll find out, though. But this should definitely at least write the 0th one, because it will hit 0 before exiting the loop. But we can't do that, actually, can we? Because we have to do it right before the branch. So... This is hilarious. Like, I don't feel any dumber, but my brain isn't... My brain is definitely not giving me the answers I usually do, and it's just being in front of camera. It's a very funny feeling phenomenon. And I've also done this more than once. So let me think this through. We'll start with x as 64. We'll add 64 to this, which will be one too many, interestingly. So, oh, you know what we can do? I think I've seen this hack before, and it's what I'm going to do. I'm actually going to add BF. Who knows if this is the right way to do it, but this way, since our added value is actually 1 under, and this is 1 over, it'll work out. When this hits 1, this will only add 1 to it, which will get it to C0. Yeah, there's a hack. Thanks. He says, Trey says, camera is hard, you're doing fine. I appreciate it. I mean, I'm not feeling too fussed, like, I put myself in this situation. You know, I'm not like... It's just such a funny feeling. Okay. So that should be, like, our whole fill loop, I think. I think that's it. Like, the attribute table would be filled with all zeros after this if this works right, which... Oh, you know what I have to do? You know what I have to do that we forgot about last time? I have to find this place... There it is. Where y'all told me I misspelled background so vehemently. There. There. Fixed. I hope you're happy. Anyway. So I think my logic held, but with assembly, your logic can get screwy so fast. So x starts at 64. We load the immediate value hex 23 into A, which is, let's make sure, should be the high byte of the base address of the first attribute table. Is 23. We write that to the address register. Then we take x, we move it into the A register, clear carry because we're paranoid, then add whatever x is to BF, 1 less than C0, which is the low byte of the video address. Then we store that into the address register. Then finally, we load a 0 into A, store it into the data register, which should write A into whatever address this is. But it's way easier to set up DMA. Then we decrement X, which hopefully, I believe TXA, which is, it stands for transfer X into A. I am fairly certain that that just moves X into A, that it doesn't like swap them. because we don't want to lose the value of x. Then, finally, we decrement x, and if it is 0, if it is not 0, we jump back to here. If it is 0, we just fall out of this and continue to set the MMC3 mapping and move on. So, this is the part where I grip it and rip it, grab all of this, throw it into the online assembler. What I've decided as far as assembler is, so here's the thing. I think I was mentioning a little bit about this before, but the deal is, so the whole idea here is to eventually get Microsoft Basic ported over to this thing. Once we've, got our basic character I/O stuff working. Nope. I am not on a Mac. It is not Meta V. And I really don't want to have to do more work on that than I have to. So what I would like to do is use the actual assembler that they used. Not sure if that's actually available. If anybody knows whether it is or what it is, there's write-ups about it, so I'll be able to find what it was. But no idea if it actually exists or if I can run it, if I'll need to run it in DOSBox or something else weird. Because they actually originally assembled it on a PDP-11 with a simulator. That I do know. But anyway, because it has its own lots of weird macro syntax, I would prefer to do that. So it's only when we're going to start actually pulling in the Microsoft Basic source that I'm going to start thinking about using something besides this assembler. But that said, let's see. Yep, our code is in here. So build it. Assembled. Download. Generate it. Save it. And let's call this... What is today? It is 8/5. 8/5. First attributes first pass .bin. And as usual, because like I said, we're just going to throw this straight on the cart. Firstly, for reference, let me get that back in. This is what we have on the cart. Are you going to work for me? Yeah. So this is what we ended up with yesterday, which is basically what we had before yesterday, but the background color is black now, as opposed to gray. It was just gray before. Otherwise, it's exactly the same. So presumably I'm doing a bunch of stuff really wrong, or like none of the attribute tables are using palette 0 right now. And I did set palette 0 correctly, but they're not using it. So they're using some palette that's currently full of grays and stuff. That would be the case if I was lucky, but anyhow. So that's what we have to work with right now, or where we're working from. There we go. So, actually, you can watch me pull this out and put it in the programmer, because that's entertaining. Also, I will remind the crowd, just because I've been shilling it, and the only reason I'm shilling it is because I'm a music person. I love music. I like sharing my weird music that I listen to. So there is a Discord, and I don't really use the Discord for anything except for I mean, I used it to announce this video and stuff. And when the power went out 2 videos ago, I dropped the results that people watching the stream did not see because my power went out. So you can get that kind of inside information. But mainly, you can see what I'm listening to right now on Spotify, which I think is a cool feature. And a lot of people who tuned in will know that I was trying to stream my turntable, and my connection is so bad that it just was not very good. So the Spotify thing should be slightly better, if less cool. So, let's have a quick pause, and I will actually drop a link in real quick. Here you go. Not forcing you to join, but you can listen to the music I'm listening to right now, and it's good. Okay, so the thing is in the thing, and we're gonna program it. So, load that binary we just made. 85 attributes, blah blah blah. Can you see the shirt? How are you even seeing the shirt? I got this from, now I'm forgetting, Freeware, you know, W-E-A-R. If you go to my Twitter to shill more of my personal account stuff, I really don't care about you guys. I mean, I'm flattered if you guys follow me and whatnot, but, like, it's not a big deal to me. But there is definitely a link to me getting a bunch of freeware merch recently that I have pinned on there. So it's also references the freeware account on Twitter. So if you want to get some cool stuff, freeware, basically, if you're not aware of them, they make a bunch of different merch and stuff for like open source projects, and it's a handful of stuff. Mainly, I wound up there at all because the Haiku project has some merch on there, but the idea is they print the merch and stuff, and they give a percentage of the proceeds to the open source group that you know it belongs to. So it's kind of cool. You can support projects, and also there's a lot of stuff. Their stuff is really cool, like this Kernahan and Ritchie C language book shirt. I thought this was very cool. I also have a Vim mug, I have an OpenBSD cap, and I have a Haiku hoodie, and I'm very happy with all of them. So do recommend, highly recommend. Anyway, okay, let's get this thing programmed. Offset 10,000 hex. And looks good. Program that bad boy. Bam. Okay. Pop it back out. Look at that. I am almost learning my macro keys that I've set up for myself. It's getting there. And I'll just put this guy back in, and we'll watch it not work at all, and then we'll move to the emulator. This is my goal tonight. Is we're doing a late night stream, and I'm going until I have some kind of text printing on the screen. I want at least a basic character print function that I can pass a character into, and it will print to the next location on the screen. That's my goal. So this, we might be here a while. Okay, hopefully that's in there in some way that's making good contact. To the video capture. Cross your fingers. Oh, the NES assembler I mentioned, that's I don't know what it's called because I don't remember. It's the one that whatever one Microsoft used to assemble Microsoft Basic for 6502 when they were originally working on it. So I don't even know if it exists still and you can get it anywhere. Don't know. Hey! I think that worked. It's very funky looking. The signal is Garbo, but those look like the colors I set up kind of roughly. Interesting. They definitely look different. I guess here, let's try something. And then we probably should move to the emulator anyway, because this is going to be slow, as cool as it is a way to work. But yeah, let me pop this back in the programmer, and we'll just adjust the program just enough that, like, we'll just change one of the colors to a different palette value. Like that, the green color that I set is theoretically color number 3 in that palette. And if we change that to something radically different, all of that green stuff on the screen should change to what I wanted to change it to. And then we can move on to clearing out all of the name table memory, which the name table, again, is what maps tiles to chunks of space on the screen. And so clearly that's not cleared out either right now. I am currently inserting, if you were following along one of the first things that I managed to get going was we found an A character in the character set, and the first character on that map is currently has that A written to it, and you can barely see it because it's like up in the overscan area. So that's going to be an interesting thing too, is I have to see how much usable space I really have, and like it looks like I'll have to like move down a whole tile row or two and just waste a couple rows. But that is what it is. But yeah, that's all I've written to the name table, so I need to also clear out the name table, probably just using a very similar link. Yes. So back to the assembler. Here, let's do our work in here so that I have it saved and I don't lose it. So, right, let us... Where is the palette 3? So this is the one that sets palette 3, and we're currently setting the color, or the third color for palette 0 to 1A, which the NES, as far as I understand it, has these hard-coded colors available. And like 1A is the greenish value. Yeah, so 1A is this greenish value. Oh, I almost did it again. Haha! Sorry, okay. So here's the spot that's setting color 3 of palette 0 to 1A. There you go. Now you can actually see it. So 1A is this greenish color. Let's set it to 16. Because the colors we're currently setting are 11, which is blue, 14, which is purpley, and 1A, which is this greenish color. So that kind of matches with what we were seeing on screen. I think that is reasonable-ish. So yeah, let's move it to 16 and see what happens. Write it. Grab it all. Throw it in the assembler. Assemble it. Get the binary. Save as... I'm just going to keep going with my... I'm not going to overwrite anything. We're going to have historical versions for days. 8.5 is what day is. Attributes change palette dot bin. Load it up. Yes, change palette. Load it at 10,000 hex. Okay. Program it. Done. Pop it back in the horribly mangled, screaming, please kill me, Super Mario Bros. 3 cartridge. This cycling is going to kill this eventually. It's not a question of will it, it's going to happen. And we're just not going to think about it for right now. Hopefully that's good enough. And there we go. Okay, so I'm doing it right. We are correctly setting palette colors, correctly setting attribute values. So, yeah. Hello, are you a hacker? In the most traditional sense. In that all of my work is a total hack. Okay, so now it is time, I think, to write some code that will just, well, okay, here, let's start here, because I know, hi, my connection's been worse, it's fine. since I'm gonna need that assembler eventually, let's just see if it exists first, and we can try and start using it. Why not? Let's see. So it's archived from this blog post. Let's see if he mentions the assembler in here. Language. Like the 8080 version, the 6502 version was developed on a PDP-10, using the Macro 10 assembler. Oh, yeah. So, that is not going to be available. Because that is going to be... I think if I remember now, like, something's coming back to me. I feel like they are using macros so heavily. Like, this is a assembler for the PDP-10, like, that assembles PDP-10 assembly, I think, and then they wrote macros for it so hard that they could assemble 6502 assembly using the Macro 10 assembler. I think that's how that worked. So, damn it. That's fun. So we're gonna have to clean it up. So I guess we might as well just use whatever assembler is convenient. Thank you for streaming. I am learning a lot of things from you. No problem. I'm just doing this because it's fun for me. Like, this is a project that I wanted to work on just for fun and stupidity anyway. So I thought, I have a YouTube channel, why not just start streaming it and give me a reason to keep coming back. Oh man, I hate missing context in chat. So Dirt Piper says, most traditional would be in the context of model railroading, I'm afraid. You're a macro. And Dirt Piper, I have no idea what the context on that is, so I forget what I've said like 3 seconds ago. So, with regards to hacking, oh yes, MIT Model Railroad Club. I have read my books on the topic, and I have forgotten everything about them. Oh, do you do model railroad stuff? I'm waiting for, you know, I've got the basement now. I've got all the weird hobbies, and now I'm just waiting for model railroading to become really interesting to me, which I bought an HO train set for putting around the Christmas tree the first year we moved into this house, and I was a little bit afraid that it awoke something in me, and I'm trying not to think about it too hard because I don't want to become dad in the basement with the model railroad set. Not to besmirch anybody with the model railroad, it's just I've got too much going on already. Pre-war, that's hardcore. I mean, I don't know anything about model railroading, really, but pre-war anything sounds intense. Model deck. Oh, you know, somebody made a series of, I think maybe they showed up on LGR, but somebody made a set of, like, IBM mainframe room, like 60s mainframe room, like System 360 and stuff, really detailed miniatures, and I'm not really, like, into miniatures, but fuck if those aren't really cool looking, but apparently you can't get them. Like, they made a run, they're crazy expensive, and you can't get them. So that's just as well. Anyway, so let's choose an assembler. Let me look really quick, because another reference for me here that I have talked about before is Baymao, who is a guy who has been pretty quiet lately, but has a history of doing really cool. He built, the reason that this is relevant is he built a more or less 6502 compatible CPU out of TTL logic a long time ago. And so he actually himself ported Microsoft Basic to that. So there is some history here that I should hopefully be able to steal from him. And I wonder if he mentions what assembler he used. CA6T, is that related to the guy who makes those super fine computer room models? Oh, assembler, CA65. Right. That's the one that I've had in the back of my head. So probably. But I still want to see what BMAU used. So BMAU Microsoft Basic. And does he mention... Scanning, scanning, scanning. Because this is where he mentioned... Ah, okay. This is where he mentioned, and where I got the information on what he had to do to change the source to work with the assembler he was using, because obviously he doesn't have macro 10. So, up until now, all the assembly code I've written... Here, let me blow this up for you a little bit. Up until now, all of the assembly code I've written has been assembled with an assembler called Acme. I've made lots of changes to Acme so that it supports all the instructions and addressing modes that are unique to BMAU. Thankfully not a problem we have. The MS Basic code I used was written for the CA65 assembler. Ah! Ooh. Maybe this is what I'm remembering, is back in this blog post, I think I may not have read thoroughly, because I think what he was saying is... this was macro 10 syntax, and they actually changed it to something more usable. We will have to see. Hopefully. Maybe. Anyway. There goes the camera. So CA65 sounds like the universal answer here. Oh, okay. So yeah, I misunderstood what he said in here. I didn't read it very thoroughly when I read it. That code, if it's the same code he's talking about, is the same code that I'm looking at here. It's for CA65. Okay. So we might, at some point, just have to try grabbing... Reconnected. Yeah, just take that code, chuck it into C65, and see if it builds. Anyway, so everyone's saying CA65, left and right. Let's go ahead and download it. Oh, yeah, Narion, if you go back to the very first rant that I did on the series about exactly... Oh, because it's part of the C... I've heard of that. Yeah, I know what this is now. So anyway, Family Basic. Yes, aware of it. That's too easy. I don't have anything better to say to that than... It's not that, like, I'm trying to show off. It's just that it's for the fun of it, and also, like, getting Microsoft Basic onto here is fucking dumb. So, I'm into it because it's fucking dumb. Pretty much it. But yeah, Family Basic exists. There is no source for it, so you could try doing a ROM hack, because the thing here is, part of this project, we're going to have to build a keyboard because there's not an NES keyboard. And the keyboard for the Famicom that came with Family Basic uses a port that and signals that don't exist on the NES. So we have to make our own work in a slightly different way. So I'd have to change the way its keyboard routines work anyway. Yeah. And then baked on top of all of that is I'm using a hacked Super Mario Bros. 3 cart. So... unless I pop out the character ROM and put in my own character ROM, which we could do that, maybe, at some point. But I'm working with what I've got, so it's not like we have a whole repro cart to deal with, or like a flash cart that I'm working with here. So, like, I don't have this that they had in the Family Basic cart, so that would be another hitch. So, many reasons, most of them stupid. Let's get CC65 so we can use CA65. Where is the actual download? I was just at the links. Is it Windows Snapshot? SourceForge, gotta love it. It'll never die. Will it be cool to see MS Basic on the NES, or stupid? Or a little bit of both? I'm thinking a little bit of both. Okay. It's downloaded. We'll just hope that there isn't any spyware in it. God, and it's 11 megs. but it's SourceForge, so it's gonna take a minute. Let me peek really quick, because my Discord has been dinging, and I can only assume it's related? Oh, because people have been joining. Hello. Welcome, everybody. I mean, I know you're definitely watching right now, so... Anyway, just a reminder, because I am, my session disconnected right as I was saying that. They don't want you to know that you can listen to what I'm listening on Spotify right over here. And my music is cool. All right, it's downloaded. And I assume I just put it in my path and call it a day. Connection's getting spotty. It's getting spottier and spottier. Maybe they do late night maintenance. Maybe that's what goes on. Yes, so I am slapping this into a CC65 folder in C, and let's just see what my current path is. Can I just do plus equal? I should know this. And this is going to be C. Whoa. C. Great, so my path probably just has a random C at the end of it now. Nope, because apparently that's not the way it works. Apparently you can't just do that. Well, that's kind of good for me. So env path equals. Let's do it this way. env path semicolon. Yes, this is Windows. C. I can't see what I'm typing on this keyboard. CC65 bin, and hopefully that will be good enough. Yeah, cool. It added it. Whether it will work, who knows. Hey, it's in my path. Let's put that in my profile really quick. Not now. Sweet. So now every time I start a PowerShell, it should automatically stick that in my path. That's the hope. So, I wonder if my code is actually compatible with CA65. Here, let's just full screen this. Where is this? NES source. That seems right. Yes, I trust myself. And F it, let's just rename this, I don't know, main.sm. Or let's call this like testing.sm. You know, you say microwave interfacing with the Wi-Fi, or interacting with the Wi-Fi, but interfering, that's the word you used. I'm directly wired in. It's just my internet being that shit. Tell your neighbors don't move their router. Here's the question. What is everybody doing on my local node of my cable network at 11:25? It's all the old folks in this neighborhood watching porn. Alright, anyway, let's, I don't know how to use CA65, so let's... Oh, come on! It's now not in my path? Come on, bro. Okay, let's just set it manually. We'll figure out what the issue is there later. Cool. So do I just do CA65 Test.asm, can I do O? I don't know, test.bin. I probably need to specify that I want bin output. Testing.sm. Yep, and that's what I thought, is that these macros are not, or these directives are not going to be supported. So let's find that CC65 manual. And we're back. Yes, let us look at expressions, symbols and labels, scopes, pseudo variables, pseudo functions. Let's see. Surely there is some equivalent to fill. Or not. Control commands. Maybe. Address, align. Bank bytes, BSS, char map code, constructor. Yes, it is Comcast. What you gonna do? One internet provider, that's all you get. Global, high bytes. Come on, it's gotta be in here, something to fill out. I mean, maybe with CA65 I can just use org, because I've seen examples where they just use org and they don't like actually fill memory between areas. Repeat. That seems right. So it can probably repeat blocks of code. Wait. Repeat. Alright, repeat all commands between repeat and end repeat a constant number of times. The command is followed by a constant expression that tells how many times the commands in the body should get repeated. Optionally, a comma and an identifier may be specified. If this identifier is found in the body of the repeat statement, it is replaced by the current repeat cap. Alright, let's see. So, I think, let's see. The fill is done by the linker. The linker? I guess since it's a compiler, I like that. That makes sense. Damn. Okay, let's do this. Let's org, because I would rather not do it that way. Let's see if I can not do it that way. Let's org at 0 and then use repeat to do the fill. That is probably a thing. Yeah, because I mean that's basically what they're doing here. And then end rep. We'll see if that works, but hopefully I can do something like that. And since I mean, org 0000 is probably implicit, but whatever. Should make it work the same, hopefully. And then here, this actually uses some math, so